Good afternoon, everyone. Welcome to our Services Showcase Pavilion. I'm Julio. During this presentation, we are going to be using an application. It's called Poll Everywhere. If you haven't downloaded the application, that's fine. You could also vote using your mobile phones, or you could just raise your hands, right? We love to gather some data and you guys to interact with us during our presentation. So we have a microphone. Don't be intimidated by it. We are gonna be more than glad if we could make this, instead of a presentation, a conversation, right? That's our main objective here. So the Poll Everywhere app, and if you are going to use your cell phones just with the browser, pollev.com/Red Hat 2017. So we're about to start right now. This session is Enable Agility with Infrastructure as Code. My co-presenter is Stefan Lefrère. Stefan, do you want to introduce yourself?
Sure. Good afternoon, everyone. Yes, I think the sound is good. So I'm Stefan, and I'm with Red Hat, and I run the cloud infrastructure practice. And this is Julio, my friend. Julio?
Yeah, I'm Julio. I am the principal architect for the cloud practice at Red Hat. So what we do is pretty much, we deliver solutions for our customers using our infrastructure portfolio. And don't worry, Stefan is about to get set again. I know that it's a little bit intimidating. So you don't have to worry about that. But today we're going to be having a conversation about infrastructure code. How do we get there? What are the problems? So that's our topic for today.
Okay. So as Julio just mentioned, what we want to do, so the first thing I want to ask, just by raising hands, right? We're not going to use the app yet. Who of you here represents infrastructure and operations in your companies?
That's a good crowd.
Wow, okay, majority. The reason why I want to make sure, because we are talking about infrastructure and we're talking about the code. So is there anyone representing apps or software development or anything like this? One person, that's great.
Well, two more persons on the back.
A couple of guys over there, great, awesome. So I think we have a majority of people in infrastructure and operations.
And that's what we want, right? We want this kind of audience because we are going to be talking about infrastructure.
Right, okay. So what we want to do is cover what we see in the field, what Red Hat sees in the field, what are the challenges that we see there. Then we're going to go after explaining what infrastructure as code is. We're going to cover the principles, the practices, and the goals of infrastructure as code. And then we'll go and jump into what Red Hat can do in terms of infrastructure solutions. And then we'll explain you also what's our approach with our customers to start tackling this big chapter that is infrastructure as code.
So we want to start with the survey. And we're going to start using our phones because we want to know which of the following issues are you facing right now on your enterprise. So I'm gonna give you a couple seconds, and we got our first response already. Configuration drips. 2 of configuration drips, 1 Service Pro. So
yeah, let's give it a little time here.
Yeah, a little time for you guys to answer. So I still see people putting. So far good responses, So it looks like, we got a couple more, Stefan.
Okay, good. It's good, and we haven't explained that yet,
Yes,
but we're going to
yes.
go through that.
We haven't get into detail of which this means. And this is on purpose, guys. So it looks like the number 1 item here is going to be configuration drips. Number 2 item is Snowflake servers. Oh, there is a lot of, there is one like going back and forward. Is that you, John? Okay. The number 3, Service Pro. So let's talk what this actually means in the enterprise today.
Go next. Okay. So Service Pro. So in the age of cloud and virtualization, it's made it super easy to provision things super fast. Right? Everyone's seen that. There's so many servers just popping here and there. And that has been happening faster than the ability for the team responsible to manage that. So what's happened with that is that the number of servers is growing, and the team is struggling to keep all the servers up to date, right? So it's kind of a paradigm shift. When these problems.
We are losing audio from you for some reason.
Can you guys hear me? Okay. No, so for some reason. So when the problems are discovered, the fixes may not be rolled out timely, and basically the team that are responsible for maintaining are affected. So the difference in versions and configurations across servers mean that the software and the scripts that work on some machines may not work on others. And that leads to basically the next thing, that is configuration drifts. And I think that's where we've had the most response there.
And who responds for Serverless Pro? Could you raise your hand? So we have our response for Serverless Pro. So let's talk about configuration drifts.
Right.
First, who responds configuration drifts? Because that was our number one. And this is usually what we see when we are on the field. We have most of people telling us, one of our biggest problem on our enterprise is configuration drifts. Is how are we fixing that? So we could go a little bit into it.
Right. So when servers are initially built, they are basically consistently built, right? But over time, then configurations might change, and that's what we mean by configuration drift. So let's give some example. Someone makes a fix to one of your local servers, right? But then to fix some issues, but doesn't have time to just address the other local servers. 3 different people are going to install an IaaS server, right? But they don't have a chance to kind of like address the whole population of IaaS servers because there's just not enough time to just go on that task, right? So the problem is not that the variations are, an issue. It's just that the variations should be captured and managed in a way that makes it easier to reproduce.
So how many of you are leading ops teams right now? Who are operations leads here? We have a couple hands up. Who are managers? Like the one responsible for the operation at the end of the day. Who are just sysadmins, engineers doing day-to-day operations? So just imagine that right now on your enterprise, you are having this issue because you get multiple people changing and fixing, on the spot. We need to change this configuration because we found an issue with this Java application server. Let's go and let's change it. But you forgot that you've changed that in 20 servers, but you may have 200 more servers with the exact same problem that you didn't touch. So that's what is going to get you at the end of the day in this kind of a state. It's the lack of automation. Let's continue. And we got couple hits on this one too.
I think we did, yeah. Snowflake servers.
Who is having that issue right now?
Yeah. So just what we mean in Snowflake servers. It's special in a way that it cannot be replicated, right? How many times I've seen so many operation story whereby this server was built by this long gone contractor here. He has a password there. Nobody knows what this server does. Right? I see a lot of nods here, like people are smiling there, right? Don't touch it. This thing just does what it does what it's supposed to do, and then somebody will want to take the bull by the horn. Let's unplug and see what happens. And disaster happens, and let's put it back and never touch it again, right? That's the Snowflake server.
I bet that everyone here that touched a server at least on operations seen that happen. One of the funny things on my career is I went to one of my previous customers and they unplugged a server. They went to decommission a server. That wasn't documented what the server is doing, and right there they lost one of the email transfer for the whole company. Like all their applications were going through there, nobody knew about it. So you are in that risk of actually impacting production workloads because you are maintaining a Snowflake server that you don't, that you need to ask yourself, how did I get there? So let's push the other one.
So yeah, and just to continue on that, the problem is, it's when the team that owns the server does not know how to rebuild it. That's when we get into huge issues, right? And so it's not about, it's different. It's that, I'm not able to rebuild this, right? That's what it is. So what are fragile infrastructure? It's basically Snowflake servers at a larger scale, right? So it's easily disrupted and it's not easily fixed, right? And the solution there, it's basically to migrate everything in the infrastructure to a reliable, reproducible infrastructure one step at a time. So that's what fragile infrastructure. It's Snowflake at a big scale.
So let's ask the question again, because we didn't got any hit for fragile infrastructure on our initial survey. Who is running into this issue right now? Let me re-ask this. So now we got new hits into fragile infrastructure. So we don't want you guys to be there, by the way, and you guys don't want to be there. But these problems, they don't happen in a week, or in a month, or in a year. These infrastructure problems, they happen through a life of a system, through a life of a data center. And they're really difficult to get under control.
All right, that was the last point, erosion. So in an ideal world, you would never need to touch an automated infrastructure once you've built it. Right? That's the ideal world, other than support something new or fix things that break. But the issue with erosion, right, is that it's the idea that problems will creep into a running system over time. So let's give some the Heroku people, the people behind, Salesforce, are basically saying that the things that can erode a system over time could be, for example, system upgrades, kernel patches, infrastructure software, for example, Apache, MySQL, that are updated to fix certain vulnerabilities, right? Over time, this thing have to happen, and that just erodes the system. A server disk filling logs very rapidly, right? So if you do nothing, the log's going to fill up, and all of a sudden, if you don't have enough disk space, then logs are going to fill your disk, and then that may cause application issues. Another example here is to one of more application processes crashing or getting stuck, requiring somebody to log in and restart them, right? So that's erosion.
I think that we need to ask a question right now. How many of you, every week, log into a system to kill a process or to restart a process? Is that happening? I used to be operations, right? Before I joined Red Hat, I used to be operations for one of the largest clouds in the world. And you still deal with that. Like, why this application is not working, why I got a trouble ticket. Like, ops people need to deal with that, need to maintain whatever we build. So, just curious to see the balance in the audience, in what are we doing? Let's jump. So, another survey, another fun survey. Are you using an automation or configuration management tool right now? This is an easy one, yes or no. Okay? Hey, this is a really good number, This is a really, really good number. We got 92% of our people is using an automation or a configuration management tool. Now I'm going to have a second survey. Are you running your previously selected automation configuration management tool unattended? Is your tool to do configuration and automation fully automated? Okay.
That's good.
Oh, this is great, actually. 23%? Yeah, we're doing. You don't have to do anything. It takes care of everything for you. On the 23?
You call BS?
Well, it's 20 now. He just went down. So that's a really good metric. Like, most of you are using an automation and a configuration management tool, but 80% of you are not actually using that automation tool in an automated way. So.
Hello? Okay. So.
Another survey.
Somebody called BS on the 20% that just said they are running attended. So I want to highlight that. It's very hard to run unattended, right? And you say. That was before you went down to 20%, right?
Yeah, somebody have a guilty conscience and went back. So thank you for your honesty. So
all right,
we have
another poll here.
Yeah, another poll. So we have some Puppet, we have some Ansible, Chef. So more Ansible, that's good.
So the guys that said that they're running an automation system, which one is that? This one, by the way, is Terraform from HashiCorp. There's no name, that's Terraform.
But we have a sense that you guys are doing right things. So you have the tooling in place already. So you know that. Like our first survey, based on that, we know that most of you have an automation or a configuration management tool. Oh, sorry, like crazy clicker. So, Stefan, do you want to have some fun?
So that takes us to the next topic, right? Which is the automation fear spiral, right? So what is that? So I think many people have had the same problems I've had in my career as infrastructure and operations people. I use automation very selectively to build things, or to go after a specific build or specific configuration, right? I would tweak the configuration to build my purpose, right? But I was afraid to turn my back on my automation because I lacked the confidence in what this automation would do. So I would not run it unattended, right? Because I was just fearing that. And I lacked that confidence in my automation because my server were not consistent, right? And my server were not consistent. Why? Because I was just not running automation unattended, right? So this is the automation fear spiral. And so I guess for teams there that are having to face that, is that they have to break that fear and basically just go head on onto this. And so one way of doing this is picking a set of servers, tweaking the configuration definition so that you know they work, and then schedule them to run unattended, at least every hour, right? And then you go on the next batch of servers. And you do that on and on until you address all the stuff you want automated. And that way then you can be confident in your automation system. Easier said than done, right?
Super easier said than done. Who is doing that right now? Any examples? Do you guys want to share how you guys are achieving that? Or let's go to you guys because we want to make this a conversation, right? Nobody has a definitely answer, and for sure we don't. But if we all talk what we're doing, I think that we could have a good idea.
Yeah, we run Puppet every hour on a cron job.
Every hour?
So
anyone else like avoiding the fear? Oh, we have one over here.
So every new server that we build now with RHEL 7, all the configuration is done with Puppet. And so then Puppet runs every half hour. And we've just made it a goal this year that any new project platform thing that we're installing, we're going to figure out how we're going to do it with Puppet or maybe with a little bit of Ansible and make sure that we can scrap that server and throw it away and rebuild it exactly the way it came out. And it's not fixing any of our old stuff or any of our Snowflake servers, but going forward, we're just sort of cleaning the slate.
Of course. We have a conversation here right now. That's
does
great.
your stuff like self-heal? Like if I change SSHD config on my own.
Can you speak closer to the mic?
Oh, sorry.
Closer to the mic.
So I asked if I change a config file like ad hoc, if it would be changed back by Puppet. So it prevents like human error or even like a rogue.
Frustratingly so for some people. Because sometimes you're trying to test something and... So yeah, his question was, when people make ad hoc changes to stuff, does it get fixed by Puppet? And the answer is yes. Almost frustratingly so. You're trying to like debug something or play with something, and Puppet's in there changing things on you back to the way they're supposed to be, but it's good, especially for some of our environments that require really strict
Perfect.
builds.
Thank you very much.
All right.
So we're going to jump in the mid now, right? It's the what and the why of infrastructure as code. So that's the solution to this fear spiral that we see in our customers, and that we suffer that also. This is not a new problem. This is a problem that's been there forever in IT, that every sysadmin has a way to fix. Like how many here have like the 20,000 Perl script or the 10,000 bash lines of stuff, like that you try to run? So everybody done that, right? Like I am guilty of that. So
let's describe in one word what infrastructure as code mean to you. Just give one word, anything. Let's go ahead.
And you could repeat the word that you see on the screen. So
standards.
Oh.
Consistent. Ansible.
I love the Ansible one. Thank you.
Magic.
Agility.
Agility. We get lots of different words. Oh, Ansible is coming twice. That's cool.
Oh, agility, yeah.
Sleep. Oh yeah, I like that one.
Oh,
Sleep. Yes.
every ops
we all
guy
want to
loves
sleep.
to sleep.
No. Yep. Build, fix. Ansible is coming along. That's good.
So look at your answers, you know? It's like, most likely, some of you put like a different word to describe infra as code. And as an ex-ops guy, I love the sleep one. I didn't thought about that. I will type that like 20 times. Because that's what we want. We want our systems to be consistent, to run, so we could focus on other things, including sleep.
So automatic, automation, agility, consistent. You know, these are all words that are close to
Chef,
infrastructure as code.
fix, weekends, that's a great one.
Weekend, sleep, yeah, I like that. Yeah.
Perfect, let's jump.
So what is infrastructure as code? So literally, it's an approach to infrastructure automation based on software development practices, right? So that's why this infrastructure and its code go together. It's because the infrastructure team is having to borrow that from the software development team. So what it does is it emphasizes consistent, repeatable routines for provisioning and changing systems and their configuration. So basically, changes are made to the definition files, and they're rolled out to systems through an iterative process that includes thorough validation. And so with this, then the people that are in charge may apply software development tools such as version control systems, automated testing libraries, deployment orchestration to manage their infrastructure, and also open the door for them to exploit some development practices such as test-driven development that are dear to extreme programming, or continuous integration, continuous deployment, continuous delivery, right? So these notions there were very dear to companies like Google, Amazon, Etsy, Netflix. And these guys have been sort of like pioneering this area because for them, infrastructure is the business. It's just not mission critical. It is their business, right? And so that's where this notion came from. It came from these guys there at Google.
So quick question, how many of you right now are implementing infra as code? We have a lot of hands, and that's really good. Now, how many of you have development teams in-house right now? Software developers in-house. So how many of you are talking to your software developers for advising how they're implementing CI/CD pipelines, how they're using Git effectively? Is that happening? We have 1 hand, 2 hands, 3 hands, 4. Well, that's good.
So modern tooling can treat infrastructure as if it was software and data. Clearly, you're no longer managing infrastructure like the hard piece of hardware, but you're now really managing software and you're managing data.
Of course.
Let's move on to the next slide.
Yeah, let's move.
So why? So the idea is, I saw sleep and I saw weekend, love it, right? It should simplify IT operations and not the other way around, right? It should take less time, less effort to provision, configure, update, maintain services. Problems should be quickly detected, resolved, and systems should all be consistently configured at all time. That's the idea there, right? And so, therefore, adopting the cloud and adopting automation tools should lower barriers for making changes to infrastructure. There's one thing I want to add to this, is that it doesn't come out of the box, right? It's not because you just implemented Ansible or Chef or Puppet, for the matter is, that it's going to improve consistency automatically, or it's going to improve reliability, right?
Or deployment time, or time to market, right?
Yeah, exactly.
At the end of the day, as ops, as infra people, we have a job based on a business objective, right? We have a business use case that we need to survive. That's why we're doing this. Nobody builds system because we want to build a new system because, oh, it's a cool system, let's build it. Let's maintain it, let's have another platform to take care of. Like every system that you have on your enterprise, I assume so, should be there because you have a business reason for it. And getting you to a faster delivery of that business reason and getting to that objective is what should be behind this kind of reason. I'm going to implement infra as code. And Stefan mentioned something that is really important. Like, not because you have a Puppet, Ansible, or Chef, or any other automation or configuration management tool mean that you are doing infrastructure as code. That's just one piece of the puzzle. You still need to work on the other pieces. And there is 1,000 ways to do this. And every customer that I have their own play into infra as code. We have our own play that could be modified and could be delivered in 100 different ways, but it's not an absolute answer to infra as code.
The other reason that I put here is that a lot of companies have change management processes, right? And who follows that? I mean, they are here for a reason, right? But sometimes they are ignored, bypassed, or even overruled by people because they're trying to get things done, right? And so these processes, they actually struggle to cope with the pace of change that is offered by the cloud, right? And a lot of people are saying, oh my God, we got to go through change process, so, I mean, next 2 to 3 weeks, not earlier, right? So these processes are actually an impediment. And infrastructure as code help you basically revolution these processes and put them in the back,
So how many of you are cloud adopters? And I know that this is 2005 conversation. How many of you are using the public cloud? The private cloud? Virtualization? Now I'm going to mention the coolest word probably in the summit, containers. So,
all right, so let's go through some principles. I think we covered some of them. So, systems should be easily reproducible, right? The reason is, it should be effortless. It should be basically possible to just do that very easily without fear. Systems should be disposable, right? That's the example that I give, that you shouldn't have a server that nobody knows about. You should be able to confidently erase that server and rebuild it automatically. Everything, right? And that way then you become more comfortable with your practice there.
And when you mention server, we're going beyond server. We're going to your complete stack, right? Like network configuration, system configuration, application configuration, that should be your end state. That everything is defined in a piece of code, in something that is readable, something that you could do change management, that you could do source control on it. That's the idea behind it.
Right.
And going to the cattle versus pets, right? Like that should be the idea. And most of enterprises right now, we have pets. We have these systems that they are, okay, nobody could touch these.
Oh, I love the name of that server. I love to name that server. That's my pet, right?
Yes, that's my pet. That's Galaxy, or that's Luke or Leah. We've all been there. So, yeah. And that should not be the case. The case should be like, you really don't care what a server is. It should be disposable. It should be able to be rebuilt.
Yeah. So yeah, the difference between every server should be identical. What should differentiate them is that little piece of information, like the IP address, for example, or whatever is specific to them. So consistency of system and making sure repeatable processes, and also the last point and not least is design is always changing, right? You need to build things in a way that you can't predict that what's going to happen. Therefore, you need to be ready for change. And so it's basically impossible to accurately predict what's going to happen to your system. And so your requirements, so with basically the cloud age, you're going to be able to make a change to an existing system easily and cheaply, right, through your tool set. So the fact that you can be ready to accommodate any change is a principle that is running in infrastructure as code.
How many here have change boards? Like I need to put a change management request, go in front of my board, justify it, and then it takes you a month to change the system, right? Just imagine getting that board in the process in the early stage, while you define the process as a piece of software, as a repeatable set of steps, that you don't have to go and get approval to change a tiny configuration on your application, that everything is repeatable, is changeable, is documented in the software, not in a wiki somewhere, like everything documented in your piece of software.
So what are the practices that are associated with infrastructure as code? So we name one of them, definition files, right? So that's one of the cornerstones of the practice here. is that the definition file will specify infrastructure elements and how they should be configured. And the definition file is used as an input for a tool that will carry out how the work is to provision and configure instances of these elements. So for example, Ansible, right? So we use, these files are managed as text, using JSON or YAML or XML format. Next, so documentation. Well, that is kind of a paradise to be in, right?
Yep.
How many people are telling you documentation is so important, but then documentation is done eventually, and it's updated once, and that's it. This thing becomes obsolete. So we need minimum documentation, agreed, but documentation should really be part of your code, right? You shouldn't have to kind of have, an extra set of PDF or documents that just describe everything of the system. You have to have minimum documentation, but clearly your documentation is your code. It's part of your code. So it should be captured in the scripts, in the definition files, and the tools. And when you have all this together, you shouldn't have to basically reteach, and send a PDF to a team there. By just looking at the systems and with their skill set on the system, they should be able to understand what the system do.
One of the funny things of my career was one of my previous jobs. I go to this big enterprise, and I asked one of my engineers, how are we doing post-provisioning? And he asked me, we have in a script. So, perfect. So, could you show me the script? And he showed me these 22,000 lines of Perl for post-provisioning. And I was like, cool, I could read Perl, so it's fine. So I asked him another question. What are you doing tracks for any change that you do on your script? And he answered, oh, I have it on my laptop. I have a Git server on my laptop, so I am doing revision control on my laptop. So I asked him another question, like, what happens if you die? Right? So how many of you been in that situation? That there is one or two person that maintain a script, that they don't document anything, and if they document it, the comment is, fix the stuff, Like, we are there every week. It's like, that's part of the trade. So that's why getting to define your practices when you implement infrastructure as code is so important. That's why version control is so important. I have a place to put things, I have a place to document changes, I have a place to call people accountable for. Why do you change this Apache parameter? What is the reason of this change? And not only that, is then you need to have the system to do continuous testing of those changes. I am doing lifecycle management, and most people don't want to do that because it's an investment. But lifecycle management is important on the infrastructure world as it's important on the software world. You need to have your tests, you need to have your dev, and then you push to production. Because you need to realize that any change that you do on a system when you are treating it in the right way, you are going to effectively change more than one machine on your server farm, or more than one application going to be affected. So lifecycle management is also important, and it's an important concept of infrastructure as code.
Yeah. I think we need to move on.
Oh, and you have do you want to talk about the small changes? I think this is a great example.
Yeah, so it's easier, it's less work, to test a small change rather than, than a big change. It's faster to fix, it's faster to reverse. I mean, there's a lot of benefit in just going small chunks of work.
And there is another thing that I like to talk to people. Automation is no magic. Somebody has to do it manually first. Like when you don't treat automation as some sort of voodoo or something like that. It's not. Automation is a process that you already did, that you know how to do, how to accomplish. Like if you go to our Ansible community, we have like tons of cool things on the Galaxy for Ansible. Should you go and grab all these things, don't read it and push it? Of course not. Please read your code. Read what you're pushing if you're grabbing from the community. Understand what the code is doing. That's really important. It's no magic.
Yeah, I think, Julio, we have 10 minutes left.
Okay. So we need to.
So let's recap on the goals here. So basically, supporting change and enabling change for IT, that's very important, instead of being an obstacle, right? You guys are already implementing Ansible, Chef Puppet, that's awesome. Changes to the system should be routine, no drama, no stress for IT. They have their sleep, they have their weekend. The IT guy should spend time, on valuable stuff, not boring stuff. The team should be able to easily and quickly recover from failures, rather than assuming that failures are part of the design. And last but not least, improvements are made continuously rather than done through expensive and risky big bang projects, right?
Oh, we have another one. Solutions to problems are proven through implementation, testing, and you need to measure, right? You need to measure impact. Metrics are really important.
Right.
Measure what are you providing to your company by improving a process. How efficient are you becoming? Like that server that used to take 4 weeks to build for your developer, now it takes 5 minutes. So those metrics are important. Number one, because then you could be more accountable and know what you are actually changing and not wasting resources and time.
All right, so what do we have at Red Hat? Now, enough about the theory now, let's talk about our stuff.
So this is a cool slide, right? Like we are focused on infrastructure, but at Red Hat we have a great portfolio. And you guys are here because you guys are already Red Hat customers. But we like to focus on these 2 areas of our portfolio, right? RHEL, Atomic, Red Hat Storage, OpenStack Platform, and that's most of what we do every day, and Red Hat Virtualization. And then for the security management portfolio, we have the registry for the containers, Insights, Ansible, Satellite, and CloudForms. So we have this broad portfolio that we could use to treat infrastructure as code. These are tools for NN, and that's how they should be looked at, just as tools.
Yeah, and I want to mention that those tools are not going to replace.
Please join us again at the Partner Pavilion Theater for our next presentation.
Beer time, no?
Monitoring
Yeah.
OpenStack
Not yet.
Piece of Cake,
Piece of cake.
presented by Dirk Wallerstorfer,
All right.
Technology Lead OpenStack, sponsored by Dynatrace.
Okay, I think
We should go.
I think that's the voice of God. He identified before as God. That's pretty cool. So OpenStack is dear to my heart because that's mostly what I do every day. But it's a great paradigm to implement infrastructure as code. So our tooling, any Red Hat OpenStack customers here? Anyone? One Red Hat OpenStack platform user? 2, 3, 4. So we use our deployment and lifecycle management tool use the infrastructure as code paradigm. So we treat everything as a piece of code, everything is a template, and everything goes through an automation process. Everything could be automated from the beginning to the end. And that's why we are putting OpenStack here as a good candidate for you to implement infrastructure as code on your enterprise.
And if you want, you can check in those templates in your GitHub, in your GitLab.
And we are going to talk about that, right? And we're going to give you a quasi good approach to it. As I said before, there is no 100% accurate or no accurate solution to infra as code. It's just a concept that you need to do, that you need to implement to be able to sleep on the weekends. So with our OpenStack platform, the configuration for the overcloud is defined on templates. We have this concept of overcloud and undercloud, where overcloud is the OpenStack cloud that runs your workloads. So what we're able to do is everything that is defined is disposable. We could just recreate roles. Like, let's say that you have the worst event ever, like a tornado came to your data center and destroyed it. You should be able, and you are able with our OpenStack offering to recreate that complete cloud from configuration files, from these templates. All the templates are YAML files, and these YAML files define how your cloud is going to look, what kind of settings they have. Any modification to the OpenStack cloud should be done modifying the templates. That's my number one when I talk to customers. Please don't change anything on the server. You don't have to log into an OpenStack controller to do anything, or to a compute to do anything. Everything should be done on a template that is readable, that is documented, and then revision, control, and put through your automation process. I already talked about that. So anything else that you want to add here, Stefan?
I'm good. I want a beer.
Perfect.
So hang on.
So this is sort of an example of what we do for some of our customers with part of our tooling. Like, as I've been mentioned, a source control system is really important on this paradigm. For me, it's the most important part here is that you are actually putting all your code in a centralized location, that you have documented every step of every change that you did, and that you could actually go and reveal all your infrastructure just with this piece of software or this piece of code. So we are using Ansible here to automate and configure not only our infrastructure running OpenStack, but also whatever is top of OpenStack or whatever is top of Rev or your public cloud. So you need to have that tool that you could automate, that you could orchestrate things and run it constantly. So in this example, it's Ansible. Some of you mentioned that you are using Puppet, but we are Red Hat, so we use Ansible for it. And by the way, it's really cool. And then we use CloudForms to be the master of the orchestration, to orchestrate every single piece of software, to do every single action, and also to gather feedback. And we also use CloudForms as a single pane of glass. So you need to do something as an operator, you go to CloudForms. You need to do something as a user, you go to CloudForms. That's our idea. And this is an example of this paradigm, right? In how we are using tooling that we provide to get you to a place that you could get to this infrastructure, to these repeatable environments.
All right, so how we help? We are consulting, right? So we go at the customer, understand their issues, their priorities, and we use a very iterative cycle whereby we go and discover, we help with designs, we go deploy, but most importantly, we mentor teams, we enable them. We don't want to be there. We want to teach you, we want to show you how to do stuff, right? We're not here to take your jobs. We're just here to kind of like help you through that journey. You know, these tools are really cool, but you know, it takes a lot of skill set and experience to be able to make the most of them, right? So that's the process, the methodology we follow. And so the best tool here is like to really understand. Every customer is different. They have different infrastructure, different problems to arise. So we go and do a discovery workshop. This is free, by the way, right? So working with your sales account, and we go and understand, you know, what are your priorities, what are your pain points, and how we can help, you know, based on the objectives of your business. And at the end of that day, then we issue an action plan with an iterative roadmap, and we're going to help you divide all that chunk of work into very distinct work. So we have a lot of tools that go with it. For example, cloud migration using CloudForms, right? So if you're on the way to moving from VMware to whatever other hypervisors or other platforms, we have tools to help with that. So these are some of the services that we have. You know, optimizing your IT with the open management and for virtualization, that's CloudForms. You know, we have a complete suite of automations specifically to migrate, you know, from
Point A to B, yeah.
From A to B, where A can be VMware, you know.
Or it could be our own product to another version of the product.
It could be our own product. It could be on many things. And we also have, you know, tools that help with modernization of your application delivery with containers, because containers are coming big. You know, that's what developers want. All right. Well, that takes us to the end of our little talk here.